Hello everyone, this is Dr. Tariq Masood. Today I'm going to present my new lecture, Lean Six Sigma Management System, Lean Thinking Visual Management Concept. So this is my fourth lecture on YouTube channel. So before my lecture, I used to read Quranic verse. Before my lecture, Rabbi Shrah li Sadri wa Yassir li Amri wahlul uqdatam min lisani yafqahu qawli Rabbi zidni ilma. So in this lecture, I will just demonstrate Lean Six Sigma Management System overview and concept for Lean Thinking Visual Management System. So on later stage, we'll discuss in detail on Lean Six Sigma how the management system can be implemented. So in introductory for Lean Six Sigma, short story, Lean Thinking Visual Management System concept. So this is an introductory program. Lectures, probably it could be of 40 to 50 minutes. So I will try my level best to keep it 30-35 minutes. So in near future or next couple of months, I will deliver a large number of lecture on different phases of Lean Six Sigma. Define phase, measurement phase, analyze phase, improve phase, implementation and control phase. Okay. This is my first slide of Lean Six Sigma Management System. What is quality? Quality touches on all areas and disciplines, but in a sense, quality is simple. In a very fundamental sense, quality is about measures and metrics. Quality is what you measure. If you see here, so in measurement concept, think quality, this demonstrates how important quality when you are in manufacturing industry. Similarly, in process improvement variations, if you can see if there is a improvement process and you can determine how the quality can enhance gradually at certain period of time. That is the part of quality, have a different concept and as per your business requirement. Okay, in quality frameworks, there are a large number of quality measurement management systems. In the top of the list, you can see the Lean Six Sigma, DMAC, DFFS, DMADV, and Lean. DMAC, define, measure, analyze, improve, and control. Define for Six Sigma. Define, measurement, analyze, design, and verify, and that is lean process. So another ISO 9001, IAS 9001C, SEMI, ITLE, Malcolm, TL 9000, and many more quality systems. So it would demonstrate where you are and how you can improve the quality, that have a different metrics and different parameters in order to identify your weakness and your strength to improve your quality, or other way to quality insurance or ensure your quality. Okay, now this is my fourth slide where I can demonstrate Lean Six Sigma versus other quality frameworks. What is the objective of Lean Six Sigma? Lean Six Sigma can be implemented by itself, but it works with other quality frameworks. Lean Six Sigma focuses on eliminating wastes, reducing variations, fixing problems, and optimizing and improving process. So here you eliminate waste, reduce the variation. If you can see the different colors and different where you are and how you can improve, and fixing the problems here, and here the process improvement. The most importantly, all quality management system frameworks complement to each other. The implementation of other quality frameworks depend on business need and improvement objective, where we are, where we want to be, what are the key parameters, what our focus and what we want to enhance or improve. In Six Sigma origin basically was created at Motorola in the mid 1980s to solve systematic manufacturing problems. Six Sigma is a formal methodology that utilizes quantitative technique to analyze data, to measure the problems, pinpoint root cause, or to determine or to see a RCA root cause analysis technique and validate and verify solutions. The term Six Sigma describes the overall strategy behind the methodology that seeks to identify and eliminate sources of process variation that lead to defects, scrap, and reworks. So when you identify defects, scrap, and reworks requirement, based on that you can implement how the Six Sigma can improve your existing system performance. Now, in this slide, I'm going to discuss Six Sigma is a tool, but the tools that can be used on projects differs by the type of project, by the industry, by the characters of the problem, and the availability of the data. Considering the tool used by the different professions, electricians, plumbers, carpenters, and doctors. As you can see, these four different professions are using different tools to identify and to fix the issues. These type of problem solvers use different type of tools. Will you ever need to use all tools on a given project? Answer is no. No, probably not. So different tools have a different specific and characters to determine different type of problems, but they cannot be implemented in different areas. So that's the reason. So these tools are tailored on a specific area to determine the problem and address the issues. Now, Six Sigma is matrix-based principally tool, focus on data management system, type of data, the quality of the data, and from where the data received, focus on evidence. When you can measure what you are speaking about and express in a numbers, you know something about it. But when you can't measure it, when you cannot express it in numbers, your knowledge is of a mager and unsatisfactory kind. It may be the beginning of knowledge, but you have a scarcely in your thoughts advanced to stage of science. So principally, more important, if your thinking, your speaking, your expression cannot be converted into the numbers or in form of some type of quality, it's mean you know something about it. But when you cannot measure it, when you cannot express it into numbers, so it's mean you still need to learn how different value can be converted into the values. William Thomson, Lord Kelvin, popular lectures, he mentioned, as stated above, in a good wood test, all other must bring data. Damning mentioned, the data is very important. If you have the data, you have the evidences, then you can set up, you can simulate the problem, you can identify the weakness and strength of the issues, and based on that you can find the solution. If you have incorrect data or data quality has been compromised, then it's very difficult to achieve the results. Too many projects ended up failing because they solved the wrong problem or solved the problem wrongly. That could be the second phase if the data is incorrect. Now, just to demonstrate further why the data is very important, what is the Six Sigma as a symbol? Now, Six Sigma is a letter of the Greek alphabet. Mathematicians use the symbol to signify the standard deviation and important measure of the variations. Now, if you have the data, if you draw a curve, you can see the curve here, the wide variation over here, and the second curve is the narrow variations here. So this is depend how you measure, how you populated your data in form of graphics presentation. So these variation designates the distribution or spread about the average of any process. The variation in the process refer to how tightly our variation outcomes are clustered around the average. No process will produce exact same output each times. So when you have a different samples of your data, it does not mean each time you have received same type of sample of same level of accuracy of your data which you have received. So exactly no process will produce the exact same output each time. Each time it will show some deviation or variation. It means the system is performing. If you received every time exact same data, mean that is something wrong. The data is freezed. The transmitter is not functioning. The measurement has issues. There's a calibration problem. So that is different problem than arise when data accuracy become a challenge. What is Six Sigma as a value? Sigma as a measure of deviations. The mathematical calculation for the standard deviation of a population is as given here. Sigma will determine how much standard deviation has been occurred and produced wherever. So by using a different parameter one in the equations. By defining the standard deviation is the distance between the mean and point of inflections on the normal curves. This is the mean value here and this is the pointed inflections. So the deviation between mean and inflection will demonstrate what is the type of the standard deviation occurred. Sigma can be used to interchangeably with the statistical term the standard deviations, and standard deviation is the average distance of the data point away from the mean as distribution. This is point over here. Now into my next slide here. How is Six Sigma achieved? By identifying eliminating sources of the variability and thus reducing potential for errors and deviation from the desired target or mean. Now if you can see here, left side is my lower specific limit here and right side here is my upper specific limit. In the blue color, first I demonstrate in plus minus 3 sigma in blue curves, and if you can see here the blue curve here, my old variation is large variation here. Large variations compared to the mean value. This is my mean value here. And when I have converged these 3 positive and 3 negative sigma into 6 sigma, if you can see here, my deviation reduced considerably. This is my new deviation from the mean value. So my deviation reduced. So that is how, if your number of sigma increase, your deviation will start reducing. But at certain period it's difficult to further measure or further reduce. So ideally, so I would say the 6 sigma positive negative at the maximum value you can achieve by implementing in a standard way. What is 6 sigma as a measure? The probability of creating defect can be estimated and translated into sigma levels. As I discussed my earlier slide, so we have 2 levels. One is a LSL level, lower specific limit, and upper specific limit. Minus 6 to plus 6 sigma's value. So if you can see here, as your deviation, large deviations and your minimum deviation where you can stand 68.26%, 95 and then 99%. So the higher the sigma level, if you go to minus 6 to minus 7, minus 8, the better the performance. 6 sigma refers to a process having 6 standard deviations between the average of process center and the closest specific limit or a service levels. As you increase the number, so the sample time it will reduce, and based on that you can fix the issues. As smaller the value, then the higher the performance can be fixed and can be addressed. What is Six Sigma as a matrix? As you can see here, it is used to serve as a different purposes and may be used at different levels in the organization to express the performance of the process, meeting the organization requirement or customer needs. If you can see in the graph here is showing the different deviation at different levels. To measure the deviation, we use a different method and different courses like defects, DPU, PPM, DPMU, RTU, FTU, and Sigma. These are the different units to measure the deviations or quality parameters when you need to determine how the system is performing. These are certain metrics that we are used in the Six Sigma to measure different type of metrics. Now, what is measuring? What we are measuring? What Six Sigma level is? Statistically used to describe the performance of a process relative to the specification limits. Number one. Number two, number of standard deviation from the means to the closest specification limit of the process. If you see here in 1 sigma here, the curve will demonstrate some deviation here, and 2, 3, 4, 5, and 6. If you can see here at the 6 here, at the US level, upper specific limit here, and you can see the deviation is very narrow. Likelihood of failure decrease as the number of standard deviation that can be fit between the means and the nearest specific limit increases. So if we can start from sigma 1 to sigma 6, so here is from mean value to up to here is very slight deviations. So mean it can improve up to 99.9999%. So that is showing over here. Now, the definition of sigma is, here I will discuss a measure of goodness by using universal measurement scales. This thermometer, this is my sigma here from 3, 4, 5, 6, and 7. Increase your sigma level exponentially and decrease the defects. In 3 sigma, I have 66,000, 4, 62,000 defects per million opportunities. At 5 sigma 200 and 6 sigma 3.5 defects per million opportunities. So if I go further, so it can be 0.02. So based on that, if I increase my sigma level, so DPMO will reduce drastically. Okay, in this slide, 6 sigma is virtual perfections. What is the virtual perfection here? As I discussed in my earlier slide, so as you increase number of sigma here, your defect will be eliminated per million opportunities. So if you can see the 6 here, as I discussed in my earlier slide, so the earlier slide demonstrate when you 6 sigma here, so your defects will 3.5 defects per million opportunity near to the mean value. So it will show 99.99% in specifications. So if you go to my next slide here, so we'll do a comparative analysis of what is 6 sigma looks like. Now I have 2 cases, 3 sigma quality management system and 6 sigma quality management system. In my 3 sigma quality management system, it demonstrates 3 key elements or 3 improvement factors. 1, at least 54,000 wrong drug prescriptions per year. Number 2, 27 minutes of dead air time per TV channel each week. Number 3, 5 shots or long landing at Harare airport each day. If I compare with the 6 sigma, so it demonstrates me entirely different values. Number 1, 1 wrong drug prescription in 25 years. 1 second of dead air time per TV channel in 16 years. Number 3, one short or long landing at all US airports in 10 years. So generally, the product and services involve how human safety, health, and money are most likely to strive for Six Sigma quality management system. So the quality management system are more prompt for medical sciences and civil aviations to enhance, to improve their safety standard to improve for humanity, for where the humanism are, for human safety. Okay, in my this slide, what is the Six Sigma? So here I have demonstrated y-axis and x-axis my business impact and how the Six Sigma philosophically can be implemented. If you can see here, if the matrix 3.5 defects DPMO per million opportunities and improvement methodology, if I implemented DMAT and management system improvement for dedication resources, data driven and customer set focused. So if you can see here, when we started the matrix at 3.5 improvement method implemented, and then there's a huge benefit, huge impact on business improvement, customer satisfaction and customer focused. So on my next slide here, what is Six Sigma as method? DMAC, define, measure, analyze, improve and control, provides a method for the applying the Six Sigma philosophy in order to improve process. So business opportunities, the process current state, determine root cause or y into f axis or the numbers, eliminate waste and variations, evidence of the sustained result. So this is my last slide. Just I demonstrated a Six Sigma methodology approach. In my next slide, we will further discuss Lean Six Sigma and Lean management system. Thank you very much for giving me your precious time and watching my video. Please keep in touch and subscribe my channels. Very soon you will receive other videos related to Six Sigma, process optimizations and many more. Thank you very much for your time. Thank you very much everyone. Please send me your feedback and comments on t.masood.dr@both.edu and keep in touch. Please also subscribe my YouTube channel to see my new videos and updates. Thank you very much and stay blessed.